Hello and welcome to this video on equations and graphs of quadratic functions. And so you can see here in this question that we've got a graph given to us, which is going to be very important, and we've also got an equation for the graph, although we haven't really. This y equals kx squared is not the actual equation for this specific graph. It is just a general form of the equation for this type of graph. And that's because of k. K is the problem for us here. This is a number that we don't know, but we do want to try and find the value of k. So how do we do that? Well, what we've got here, we've got some information which is quite good for us. We've got the x and y value 2, 16. We've got this little coordinate pair. So we know that when x is 2, y is equal to 16. And maybe you can see from my shading there what we're going to do next, because if we know an x and a y, then we can put them into the equation. Instead of y equals kx squared, we can have 16, which was the y value, equals k, which is the number we're trying to find, multiplied by x squared, and the x that corresponds to 16 is a 2. So we've taken the coordinate from that diagram and we've replaced it into the equation in place of x and y. Now 2 squared is 4. So what we know is that 16 equals k times 4, or 4k as it's better known. And to solve this for k, we would divide both sides by 4. That would give us k equals 4. So we've found the value of k. And all that really remains for us to do in this question is to write out the equation of the graph. And it did start off as y equals kx squared. It's not y equals kx squared anymore. It is y equals 4x squared. So we've replaced the k, which was in the original equation here, with the value that we worked out with that 4, and that is the equation of this graph here. Now if we take a look at this second example, something that's really important is this form. This is a quadratic equation written out in completed the square form, so that's a really useful skill to be able to do. You should be able to write quadratics in completed square form, and the reason for that, or one of the reasons, is because it's a very, very useful form to read off the coordinates of the turning point for any quadratic equation. And this question has us doing something similar, only we've been given the turning point and we're trying to work backwards to find out what the equation must be. And this takes a little bit of thought, but what we can see here is that we've got this coordinate 4, 2, which is the minimum turning point of this graph, and the 4 is the x value, the 2 is the y value. So the y values on this graph never get lower than 2. The graph has a minimum turning point at 2, it never gets lower than 2, and so the minimum value of this graph is of course 2, and that will be b. That gives us b, the minimum value. But for the minimum value to occur, it means this whole thing has to be equal to 0. And the only way of making that equal to 0 is finding the value that goes in place of a that will make it 0. Now since we know that x is equal to 4 from this turning point, then if we make this x equal to 4, then we need to think what must go in place of a to make that bracket 0. Well, a must be negative 4. So 4 minus 4 will give that bracket of 0. So when a is negative 4, that means that the bracket will be 0 and the overall value will be 2. So how do we actually write that out? Well, a has the value of negative 4 and b has a value of 2. And you can check that all that makes sense if you substitute those values back in to this little expression. So for example, when x is 4 and then a is negative 4, 4 minus 4 is 0, 0 squared is 0, and all we're left with is b, which is the corresponding value that goes with the x is 4. So that's where b is 2 comes from. And then we want to find the equation of the graph, and that really just takes us writing out what we had, which was y equals x minus a, only we're not subtracting a or adding a, we're subtracting 4 now, so x minus 4 all squared plus 2. And that is the equation of this graph here. And maybe you can see the turning point of 4, 2. That comes from here. Remember, it's the value of x that makes that bracket 0, so that's why we need 4, 2. That's where that turning point comes from. And then we've got one more example. And this one again, a little different because we don't have the coordinates of the turning point, but we do have these coordinates. And what we do know, though, is that the turning point happens when x is equal to 3. That means a is equal to -3. So immediately we can start to fill something into this equation, and then we can head towards getting the final answer. Now, we know that when x is 5, y is equal to 6. So we can replace those values for x and y. That gives us 5 minus 3 all squared in here plus b. And the only thing we don't know is b. So we can solve this for b. 5 minus 3 is 2 and 2 squared is 4. And if we subtract 4 from both sides, we can see that b is equal to 2. So what we must do somewhere is write out our answer. It said find the values of a and b. A is -3 and b was 2. And then the equation of the graph, well, that's the original equation with our values substituted in. So x comes back, y is there, not plus a, but -3 squared plus 2.